And that should be started up. Go ahead.
Cool. Thanks, Mia. Welcome back to another review of the sync string PR from our contributor, Michael Rizkala. When we left off with the last review, I had gotten up to int sync override in the sync stream header. So I will continue reviewing there. I have not actually gotten a chance to look at the latest commit that addressed my previous feedback. So we'll be seeing what's going on here. Actually, I wonder if can I full screen this? Yes, maybe that will buy me a little bit more space. Okay, it looks like there's been a change to this file. Okay, here's sync stream. Here's the in-sync override. Okay. And let's see, I was also looking at, oh, I guess that's the downside of going full screen, is I can't easily see the standard. We just updated our README's link to the latest working paper. So if you ever wonder what the latest working paper is, the Microsoft STL README has it somewhat prominently. It took us a little bit because 4878 had to redraft our README about, oh, this is going to be the CS+20 international standard. Surprise, it's now CS+23, but we're still working on 20. So the README now clarifies that. In theory, wg21.link/stud will take you there, but that has to be manually updated, and it's not always 100% up to date. Okay, so I was going to look at the sync stream wording. There's now a new PDF viewer. That is in IO. I want to say synchronize output. There we go. No, this here. Okay, so we are at in-sync override of the basic sync buff. Okay, so as we need to look at the standard. Here I'm still just looking at the implementation for things that seem completely out of place or that I don't understand. At a later point, we can do an exhaustive review of, okay, does everything in the standard match what's in the implementation, and vice versa. Okay, so int sync override is setting this. First question I had was, it returns an int. Is that something that needs to be marked no discard? But this has side effects, so it should not be marked no discard. And it's following our newer convention of marking virtuals as override. I actually, right now, I cannot remember, and I don't have an enlistment on this machine. If we said virtual override elsewhere in this standard, at some point we did. This just says override. I think this may actually be non-conventional. I think we may still be saying virtual override. Let me check. Who's got virtuals? I know that the memory header does because it implements the shared putter. Okay, we do currently say virtual override. There's an open issue about whether we should change our convention. I was recently reminded in a completely different context about the importance of following consistent conventions. Yes, it's issue 303 that we opened a while ago, asking, should we change our convention? But right now we say both. So in this new PR, we should follow the existing convention and then later change it globally if we so decide. So I will mention this. Is this actually, this is the first override I've seen. Okay, so I hadn't missed any before. Currently, we follow a convention of saying both virtual and override, the context sensitive keyword, even though the standard doesn't quite call it that. Although we may change that convention in the future, see Number 303. Then this PR should follow the current, instead of saying this PR, I'll say I believe that sync stream should follow the current convention occurs below. Okay. This one is admittedly cosmetic. I don't expect to see compiler bugs or significant clarity issues, but following consistency when it's not too nitpicky is useful because it helps searching. When all the code, as I like to say, when all the code looks the same, then any code that's different stands out as either being unusual for a good reason or unusual for a bad reason. It may just be my brain because I noticed every small difference, but I have found that it is useful. Okay, so this thing's an overrider. We love the kind of sensitive keyword because it detects mismatches in the signature. It's so easy to end up with a virtual that doesn't actually override because it slightly differs in qualification. So we do like that. Let's see, it's plus 11. Okay, my base sync recorded is true. This is that data member in the base class. We need to qualify it because it's in a dependent base. It depends on 2 of the template parameters, but not 3. Now on the sort of convention side, I'm wondering, should we say this arrow or should we say my base? In this case, they're the same. But I want to say that in general, we use this arrow to access data members in a dependent base class. And we only use qualification when we're in like a static member function, so we don't have this arrow. I think we're pretty consistent about that. I'm trying to mentally doing a search of how often have we said my base double colon, and I do not think this is very common. So I will have another consistency comment here. So trying to decide like how confident I am in the convention. We generally use this arrow to access data members in dependent base classes. My base is necessary in static member functions where we don't have a this pointer. Believe we say occurs. It's both sync recorded and a mid on sync. Is that right? And this was the one that was defined in OStream, the common header, or no? Oh, here it is. Okay, yeah, 2 bools, a mid on sync and sync recorded. Cool. How often do these both occur? Is it only the one? I guess I can search for my base. Sync recorded, mid on sync. Yes. And also swap. I'm pretty sure we say this arrow swap. Occurs below, also for mid on sync. I'm always sort of mentally torn on does this meet the threshold for commenting on, or am I being too nitpicky? But it is simpler when you can just read a code base and you just say, oh, okay, this arrow, I know this pattern, rather than wait, it's qualifying my base. Is that for a specific reason? What's exactly going on here? Whereas like the meaning of this arrow, if you conventionally use it only to access dependent bases, it couldn't mean anything else. You're not like reaching into some completely unrelated class. Okay, we generally use this arrow to access data members dependent base classes. my base double colon is necessary in static member functions. We don't have this pointer occurs below also for mid unsync. The background there, if anybody is unfamiliar with this fun bit of standardies, is that I guess I can start a VS Code for a little example. Let's see, can I zoom in? Yes. So if you have a base class like template type name T, it could be a class or a struct, and you have either a data member, int value, or some member function. X, I can type int, and then you have a derived class that derives from base of T, and then int cube. Right. So if in a derived class you try to access names, whether data members or member functions, from a dependent base, which means that a base class which depends on a template parameter, then the standard says that unqualified name lookup, like if I just try to look at value, read from it or write to it, or if I try to call some unqualified name as a member function, the unqualified name lookup is not allowed to reach into a dependent base. So a conformant compiler is required to reject this code. MSVC was a very bad kitty for very many years and would permissively accept this code. And it has recently been changed. The permissive minus strict mode compiler option will enforce this rule properly. Interestingly, this rule is not strictly part of two-phase name lookup, which is a sort of complicated template principle, but it's related. It's a decision that the standard made. It could have gone the other way, but the standard chose to make unqualified name lookup work this way for, as I understand it, more predictable and consistent behavior when working with dependent-based classes like this. So that's why in the STL, where we have always tried to be conformant, and now we have to accept both permissive mode and strict mode and Clang and strict mode and all that. For many years, we have exhaustively tested our code so that we will have to qualify or use member access syntax to get these names. So if you say this arrow, this will compile according to the standard and in strict mode, because this goes through completely different wording that goes through member name lookup, and that will consider dependent base classes. Or in the original PR, if you qualify this with either the name of the class or a type def for it, that will also reach into the dependent base class. So that's what was happening there. This is well known when STL implementers have written a bunch of base classes, but it's easy for us to forget how confusing it all is when you first look at it, especially because the compiler error messages are generally not super enlightening. Okay, so we set, we've been asked to sync. We say sync recorded true. If my base says to emit on sync, we try to call emit. If you can't, then return -1, otherwise return 0. Okay, that looks good. Trying to think about, should this be fused with like and, but having the nested diffs is actually clearer. It's not like, testing a pointer and then dereferencing through the pointer or something, so that's totally fine. Okay, so then overflow. This says side effects, don't need no discard. We've already talked about the override. Okay, overflow takes a current elem. So if our wrapped stream is null putter, return EOF from the traits. Otherwise, call traits, ask, are these characters the same according to int type? Because the EOF character is outside of the bounds of the plain char type. It could be like -1. So ask is current elem EOF, store then a const bool. Nice to see the const local variable. If it is indeed EOF, then return not EOF. Okay. I wish I were more familiar with the overflow semantics. I believe this is something to do with like resizing the buffer. I should just like, take a month and study IO streams. Okay. So get buffer size. This is a presumably private member function that we have not yet seen. Scrolling down. Okay, it's down there. Returns a size type. Okay, go back. Store that in buff size. Ask the allocator that we're templated on, what's the maximum size of possible allocations, and store that. Okay, this is good because it goes through allocator traits. This is the bit of standard library tech that will fill in the max size function if alloc does not provide it. So we can accept minimal allocators. Allocators are less annoying now in CS+11 and beyond to provide. They're still kind of annoying to define, but allocator traits goes a long way towards making it more reasonable. So if the buff size is as big as we could possibly ever allocate, then EOF, we cannot get more. Otherwise, it looks like we can grow. So const size type, the new capacity is going to be calculate growth. I'm assuming, is this a member function as well? Or did we, okay, member function, not a non-member. This is gonna, looks like, oh, hold on, sorry, bouncing around. We're gonna do geometric growth. Yeah. So if you're not familiar with the geometric growth, this is the technique that vector and string and other STL data types use. When we're asked to reallocate, we reallocate with a multiplier. Other STLs use 2 typically. The standard leaves it, up to the implementation. We use 1.5. So if we start with 100 elements in a vector and we're out of capacity and we need to push back an element, we'll grow to 150 elements. It sort of is a compromise between fewer but larger reallocations and potentially having unnecessary slack space versus more frequent reallocations. Plus, there's a theoretical concern about being able to reuse the sort of memory leftovers. So we just consistently use 1.5, and that seems to work for us. So this is going to ask, what are other parameters here? Calculate growth, old size, new size, max size. Okay.
Stefan, we have a question in the chat.
Oh, cool. Let's see what the question is. Can I click this? Should different types have different geometric growth, or should this calculation be unified across all container streams, etc.? So that is a good question. The answer is we could probably be a little smarter about the specific growth policy in containers like vector that have user-defined element types, because in general, we want to grow by 1.5x, but underneath, the allocator probably has preferences for returning memory that are like, powers of 2. Like if we only ask for, say if we ask for like 150 bytes, the allocator could probably give us like, the next highest power of 2 without too much trouble. So perhaps that, the calculation should consider the size of the element and any, undocumented information we can look up on the allocator behavior. Aside from string, which does do such weird things, we don't do that in vector or the other geometric growth functions right now, but we could in the future. That's something that we could tune. It's not clear whether there would be significant, performance effects from like adjusting like thresholds or something, but there could be. For adjusting like the constant, I think that's less sensitive to the size of the element. In theory, if we had some sort of magic oracle, we could ask, how expensive is it exactly to copy this element? And if the answer is that it's very cheap, then maybe we would want to grow a little bit less at the expense of more element copies. But if it's very expensive to copy the element, it's got dynamic allocations or something, and it's not move friendly, then we could use a larger factor, because nothing in the STL requires like vector X to have the same growth factor as vector Y, even though that is the case in our implementation. But we have no way of querying how expensive is this thing going to be? We could ask, are you trivially copyable and so forth, as we do right now. but not in a useful way. I think that would guide that decision. So right now we're just doing the simpler thing, but we have the opportunity to make it potentially, different in the future. So yeah, I guess my answer is right now we happen to use the same calculation, but we haven't unified it, mostly because it hasn't occurred frequently enough to centralize it somewhere. But like I saw in this this PR, I saw that calculate growth function. And I was like, oh, that's the same, exact same spelling of the name that we used in vector. Did we actually already lift it out into a non-member function? I could see if we accumulated enough occurrences of this throughout the STL that we could eventually start centralizing it once we say, we keep doing this exactly the same every time. Sometimes it's an allocator, sometimes it's just operator new or whatever, but it's always 1.5. So why don't we just centralize it? So that could be something we do in the future. Okay, so this is going back to where we were, calculate growth. Old size, new size, max size. So this is trying to get one extra element. Okay. And we can form, whenever we deal with allocations, we always got to think about integer overflow because it's such a hazard. Here we've already tested, are we at the maximum size? So this tells us that we're at least one less than the maximum size, so we should be able to form max size plus 1, or buff size plus 1, regardless of whether the max allocation is like what stood allocator returns, which is, FFFFF, divided by size of t, or if the allocator is chosen to report a smaller max size, we can at least form plus 1. So that's going to be the new capacity that we calculate. The old putter is we access our streambuff type base class. Here I'm totally fine with qualifying it here rather than saying like this arrow, because it's from this specific base class. It seems fine. Although I guess that, this thing is multiple base classes. Just multiple base classes. It's got, well, multiple layers, I should say. We got the basic syncbuff impl, and then above that, you got the streambuff type. I think this arrow is fine because there's no potential for name conflict. Okay. So we ask p base, we store that in, we've got const on top level in both the pointer to lm. Awesome. So const lm start const, and then our old data size is get data size. Is this how much we're using? It's different than buff size. Okay. We're going to ask the allocator allocate up new capacity. That returns a fancy pointer, a potentially user-defined class that imitates a pointer, but we're going to unfancy that into a raw pointer. Okay. And then we're going to copy over our existing contents using the old data size, not the buff size. That's good. We set our pointer. We use sputc to add in the new element, and then we return it. Okay, that looks good. Okay, private, we've got a static const export data member, min size, constant for minimum buffer size. Thinking about naming, should this be min size or min buff size? Because it could be interpreted as this is the minimum size of the data. Are those synonymous here? Set p, new putter min size. What is the data size calculation? Is that from the? Yeah, it's that p putter p base stuff. Okay, and then when we go back up here, we set p. Okay, so I think size is actually synonymous with data size here as well. Okay, so I don't think we need to ask for this to be min buff size or anything. Okay, we've got a private init function that if we are freshly initializing the class, we're going to allocate min size, unfancy that, store here a new putter, and then you set p. Okay. Tidy is our conventional name for cleaning up any allocations we have. This goes back to vector and other STL classes. One nice thing about consistent naming is I see tidy and I've got an intuition for what it's got to do, rather than, oh, this is a tidy, this is a cleanup, this is release resources. No, just keep using the same name, which can be even more helpful when you have classes that care about it. We have now a tidy guard that's an RAII class that will tidy if an exception occurs. Although here we apparently don't need to use that. Okay, so we're going to get the buffer size, store that in buff size. If it is greater than 0, we've had some back and forth about should we write Yoda conditions where the constant is on the left. A lot of the existing code does. I have always mildly disliked this order, although it is consistent with existing code. Here it seems to be relatively unusual. I don't see any other occurrences of this. This is like right on the threshold of asking for. I think there's enough going on in this PR that I'm not going to comment about the Yoda condition here. That can always be cleaned up later if we ever decide to be really consistent about not doing this. Mostly because we're not concerned about accidentally modifying things here, especially when we're disciplined about const, and compilers are, I think, pretty good about warning about, oh, you said single equal rather than double equal. So unless we're in like a generic context where we can only say less than, I view this as not buying very much, but it's easy to read. I can see that it's buff size greater 0. So if we are tidying and we have a buff size, then we need to deallocate. So we're going to get the pointer to the base of the buffer, dereference it, and then form pointer to. This is a way of getting a fancy pointer to something that we only have a reference to. So we're converting a raw pointer back to fancy. Now my neurons are firing and I'm thinking about, don't we have a refancy function that does this? I really should just enlist in the STL here so I can do VS Code search. Did we call it refancy? We did. We have something called refancy. Okay. What happens when you refancy a thing? And give us the default branch. Okay, so if you refancy, you have to be told what the pointer type is. Oh, we have, this is currently on-off spine, where we enable one and disable the other, or vice versa. In the future, we could unify these with if const expert. At the time, we couldn't use it unconditionally. So if you are looking at just a raw pointer, refancying does nothing. We don't want to emit extra function calls. But if we have some sort of fancy pointer, we would take its raw pointer and then call pointer to. Okay. And we could probably look at usages in, that's not helpful, vector, which extensively uses allocators. Yeah. So like when we need to convert between the raw and fancy pointer domains, we'll say refancy and then provide the fancy pointer type. Yeah, so usage looks pretty simple. Would that be a clarity benefit here? We have pointer. I believe pointer is the fancy pointer type from the allocator. It is. So we could just say, I believe, refancy of underscore pointer. Oh, did I go too far? I didn't go far enough. No, I did go too far. Sorry, I lost my place. Here it is. I think we could just say refancy. Which would allow us to essentially skip the pointer traits stuff. We would still, in general, we'd have like one function call. So it's never going to be worse for a raw pointer. And then deallocate. I think I will suggest that. And the other advantage is that refancy should be able to not do that extra dereference step. Oh, I should have opened up a new tab. What was that? X memory? X memory. Half of this job is like we're trying to remember which internal headers things live in. Yeah, refancy takes a pointer and will handle the dereference as well. Okay, so I think that's definitely simpler to say just refancy the p base rather than dereference and get a pointer to. I believe that this can call refancy of underscore pointer of string buff type p base should be simpler to read and no less and trying to think of a better way to say just as good. I'm going to just say just as good for raw pointers in debug mode. Although I haven't attempted to compile this. Okay, that's why I'm not phrasing it as a suggestion, because suggestion implies, oh, you can just accept this and it's not going to break your build. I believe that this can call underscore refancy underscore pointer of string of type p-base, but should be simpler to read and just good for raw pointers in debug mode, although I haven't attempted to compile this. Okay. So if we get a buff, then deallocate, set null pointers for the string of type. If we have a wrapped pointer, then release the mutex that we were storing for it and then null it out. Okay. Have we tested wrapped or wrapped not equal null putter elsewhere? This tests wrapped equal null putter. I could have sworn I saw just it being tested as a bool. Oh, there's inconsistency here. Here it's testing not wrapped, and elsewhere it's not null putter. Here it is wrapped. That's inconsistent within a single class definition. I would like it at least to be consistent. We're nowhere near globally consistent, but at least within a class definition. I will comment on, I think here, this class variously tests wrapped directly or directly wrapped and through comparison with null putter. Just trying to be really clear about what I mean by just saying, oh, directly, which is not really a term of art in the standard. Wrap null putter and wrapped not equal null putter. I will phrase this as a style nitpick because it is. We're nowhere near globally consistent about this, but I believe that this class should pick one form and consistently follow it. I personally prefer direct testing because it reads as if we have wrapped slash if we don't have wrapped, but either test wrapped directly, wrapped not wrapped, and through comparison with null putter. The reason I mildly dislike comparison with null putter is that it's a mental negation. Wrapped equal null putter means you don't have a wrapped. And every negation is a potential for the human brain to get confused. Pick one form, consistently follow it. Okay. Good. Okay, so if we have a wrapped, then release it and set it to null. Awesome. End of tidy. Move assign is following our elaborate pattern for testing allocator quality. This uses tag dispatch, but it's one of the cases where converting it to use if const expr will be a big global thing that we'll want to do. Right now, trying to do that would distract from the code. So if we know the allocators are equal, we should tidy ourselves. We should run propagate on container move assignment to assign the allocators only when they ask to be assigned. And then we should swap with right, except not the allocator, because we've already pokema'd it. Okay, that's good. That's interesting. Propagate allocators does the same thing. Why do we implement both of these with the exact same logic. If we're already equal, we definitely need to Pokema, because this was something we got wrong in the standard for a while. We originally had code that said, oh, if the allocators are equal, saying, oh yes, I can deallocate the other allocators' allocations, then we don't need to assign them. And the standard says, actually, you do need to assign the allocators, even if they already start off equal. In theory, this could like transfer a cache between the allocators or something that's not needed for them to allocate and deallocate each other's allocations, but could have efficiency improvements or something. Even though 99.99% of allocators don't care. It is curious that these two tag dispatch overloads are doing the same thing, that we can't unify them. I'm trying to remember exactly how we phrase this tag dispatch. I think this lives in memory or X memory. I think this may be the best we can do until we convert to if const expert. This would actually be a reason to explore if const expert with a little more high priority, but not in this PR. Okay, so it's an independent struct, and then propagated, no propagator, true type and false type. So it actually is not easy / possible to unify those two overloads with tag dispatch, whereas it's trivial with if const expert. Nothing to comment here. We already have a tracking issue for replacing everything with if const expert. For now, this is great. So cool. I very much like seeing this PR follow the existing patterns that we have, because like getting all of the Pokema and swap accept allocator incantations correct for containers was just hugely time consuming, because it's allocators that care about the difference are so rare. So this is a case where just following the existing conventions gets this stuff right. For these weird corner cases. So I'd really like to see that. It's great that Mike Roscoe has done this. So if we're being told not to propagate allocators from the allocator, then if they start off equal, then hooray, we can just move assign. And move assign directly calling the dispatch for equal allocators will try to Pokema, but Pokema will do nothing because we've been told not to propagate. So this is the pattern we've used elsewhere. That's fine. Otherwise, they're not equal. We've been told we can't propagate. So we need to sort of flush the memory we currently have and then allocate fresh memory from an incompatible allocator. Because some allocators could say, hey, you're not supposed to assign me when you move assign the container, but I'm different. So the allocator that the destination already has, that needs to be used to control memory, to allocate memory. The source of the basic sync buff, I've got the memory here, but I'm not going to give up my allocation. So that's what this code path is going to handle. We're going to tidy the destination because that's being assigned to. We're going to get the buff size and the data size from the right basic sync buff. We're going to allocate enough memory from our allocator, the destination, and then unfancy. We're going to allocate the buff size. So we're going to transfer over the capacity, essentially, just not the memory. Store that as top level const new putter. Copy the contents over. From right, we're going to set our pointers accordingly with the data size and buff size. This is like my size and my capacity. Then we're going to swap our locales. Okay. Qualified to reach into string buff type. I decided I was okay with that. Had the previous comments for the emit on sync. Now that I see them next to each other, like here, this is using qualified names to be clear about where it's coming from. I kind of like this. When I saw it by itself, the emit on sync, I was like, oh, this is not consistent with this arrow. But now that I'm seeing them next to each other, this is reasonable, and it's being consistently followed. I will retract my previous comment about this arrow. Yep. Okay, I'm convinced. Qualification is reasonable here. Just because we've got these multiple layers of bases and qualifying it says, hey, this is where to find a mid-on sync. It's not all the way up in the string buff type. Okay, so that's awesome. It's going to swap all the data members and then finally tidy right when we're done because we've moved from it. Okay, that looks good. Okay, when we're told to swap everything except for the allocator, call my base swap. and then swap the wrapped pointers. Okay. Do emit is the virtual, turns whatever emit returns. Okay, I've already commented about the overriding. This is lots of side effects, so it doesn't need to be no discard. Same here. Emit. Okay, so this is a tribe again. We have elsewhere, there's no cleanup happening here. It's just a return. We just swallow all the exceptions. We essentially trying to think if this could be done with an RAI guard. Not easily. I think this is reasonable. The usual reason to use RAI guards is when we have a rethrow, and we're not simply dropping the exception on the floor. So I think that's fine. Mental question, who is calling ugly emit? I really wish we had case sensitive search. The DDoR. And of course you don't want to throw exceptions from a DDoR. Okay, great. And in move assign. Okay, so there's a reason to consume all those exceptions. Okay, what's up next? Calculate growth. This is doing pure computation, so it is no discard. May as well be const expr as well, even though nothing else in this file really needs const expr. Actually, that's interesting. I'm reading ahead a bit. I see some const exprs below that maybe should not be there. Where are the? Come on, I want to find the first. Oh, it was finding it. It was just slow. Const expr. Okay, static const expr. That one's fine. This is indeed the first const expr function I've seen. I'll comment on the ones below. Okay, so calculate growth. We're working with the size type, which is a potentially allocator defined type from the allocators type devs. Everything's top level const, which is great. We got an old size, new size, and max size. The STL is somewhat inconsistent about whether it separates different words with underscores or not. We've generally preferred underscores in new code, but it is true that for very terse identifiers like old size and new size, we often see them without underscores. This is fine. I can mentally parse this. When the identifiers get long, I'm like, yeah, we should maybe have an underscore there. But old size, this is actually the form that we've used in vector. So this is great. Okay, so this is our geometric growth pattern. We have to be very careful about overflowing because here we're not just incrementing by 1, we're multiplying by 1.5. So what if that overflows? We don't want to get confused. So we need to phrase this in a specific way. We don't want to trigger an overflow, even if it is unsigned integers, and then find it later. We need to detect it before the overflow could happen. So we can always take max size, subtract old size divided by 2. That's not going to overflow or anything. And then ask, hey, is our current size bigger than that? And so this is a way to ask if old size plus old size over 2 would be greater than max size, then we overflow. But we do it in a non-overflowing way. So if that's the case, then clamp and say, nope, you can only grow up to max size. Allocation will probably fail anyways, but at least we didn't try to overflow. And I could diff this against what we have in vector, but this looks basically identical. I do copy things into VS Code and do a diff if I'm seeing code being moved. But for existing code here, the function's simple enough that I don't need to like look at them side by side. Now that we know we can actually form this without overflowing, store that as geometric. If the user is asking for a new size that would be beyond 1.5x growth, like we're currently at 100 and the user wants 300, then give them exactly what they want because geometric growth would not be sufficient. But if geometric growth would be good, then use it. This is what prevents quadratic complexity, which is our eternal enemy. Okay, now we've got data size and buffer size. These member functions are const expr, but they are calling the stream buffs pputter and pbase. I am 99.9% sure that the stream buffs are not const expr. Please, WG21, never ever make const expr IO streams, I beg of you. So I'm pretty sure that these member functions do not need to be const expr. That should simply be dropped. I suspect that because it's only appearing here, this may have been copy pasted from above, but I'm not 100% sure. Okay, I can actually have a comment that extends across these. Oh, come on. I believe that these functions will never be eligible for constant evaluation. So they shouldn't be marked as const expr. Whereas it's fine for calculate growth, even though we don't need And then as I was typing that, I was thinking, wait, do we even need data members? Does calculate growth need to be, could calculate growth be static? And looking at it, I believe this could actually be static. This is totally pure computation that only looks at the parameters because we're told old size, new size, and max size. I think vector may have a calculate growth member function that looks at our current size and capacity by looking at data members, but this is told what they are. So I will actually comment that it can be static. Sort of it doesn't really achieve anything, and the code gen is basically going to be the same either way, but it's a little clearer saying that, hey, we don't need any state from the class. I believe that calculate growth can be static instead of a const non-static member function, as it doesn't need to access any data members. Basically the same code gen either way, but static has a slight clarity benefit, in my opinion. Okay, yeah, the only thing we get from the class is the size type def. So we don't need that to be a non-static member. Okay, cool. Okay, buffer size, pputter, pbase, epputter, pbase. Okay, this is going to be like a putter diff, so we're going to static cast to the size type. Notice car is totally fine because it's reading state out. Wrapped is a pointer that is initialized to null putter. Allocators constructed with empty braces. Okay. Excuse me. Okay, well, now we've got a swap. And recall that, did I have concerns about the no acceptness of swap? Let's see what we got. Oh, this is what I want. Swap in the class definition is not marked as no accept, but it is in this definition, and non-member swap is no accept. Okay, so it looks like there is a defect in this. I could have sworn I commented on this, but I haven't seen it addressed. No accept is in the definition there. Oh, was it in the class synopsis where, or sorry, the header synopsis? Open this up. Header sync stream synopsis is where it would be declared. The standard has conventions about where it declares things. Oh man, it's missing here too. The synopsis is just missing no accept in both places. So that's probably how this happened. But swap should be no accept. The standard doesn't throw exceptions here. Now I actually want to check, was it 1564, 1564? I want to open up the discussion tab. Read that. I want to load any comments I had about no accept, so I don't start replying and saying, oh yeah, it's not no accept. Okay, here it is. This is the move assign. I guess I just hadn't looked at the swap at that time. Okay, there is an issue about that, but not swap. Yeah, it was just the move sign. I'll comment on swap. So we're seeing it in the non-member, and was it missing on the member implementation? The member implementation has it, so I think it should be there. So this one's good. I will say this is missing no except here. And I closed the discussion tab, so I don't have the LWG issue, but confident it's being tracked. Or sorry, not confident. I hope it's being tracked. The standard is also inconsistent about swap being no except, but I believe, or declaration isn't, definition is. I believe that this should be marked as no except. The member implementation above already is. Okay. The standard is also inconsistent about swapping no except, declaration isn't, definition is. I believe this should be marked as no except, the member implementation above already is. Okay. So we're templated on all of our types, void swap, ref left, ref right, just check and make sure everything's ugly, should be no except. Okay, left dot swap right, good. Okay, that's basic sync buff. We are 294 lines into a 355 line header. Now we got basic OSync stream. I'm glad that there's no isync stream. Let's do a quick overview of the class template. Okay. Okay, allocators should meet the requirements. Okay, cool. Okay, we've got our banner comment class template, basic OSync stream. It's templated on LM traits and alloc. I believe iOS forward has already provided the default template arguments, but let's refresh our memory. Indeed, that's the case. And we've dragged in iOS forward through stream buff, I think. So those default type arguments are visible. We derive publicly from basic OStream LM traits. We provide a bunch of type defs. In the previous review, we found some issues with the type def, so let's double check. Can I just make this? Nope, I don't want to maximize. There we go. Just checking their presence. We got the char type, int type, pos type, off type, traits type, allocator type, stream buff type, and sync buff type, and an ugly MyBase. And a partridge in a pear tree. Okay, so that's good. So char type is LM, in type we get from the traits, same with pos and off type. Trait types traits, allocator type alloc. Stream buff type is basic stream buff, sync buff type is basic sync buff with the allocator. MyBase is the basic O stream. Useful for construction here. Okay, so we've got constructor. Here I do like to cross-reference with the standard because a common thing I found is explicit is very easy to mismatch between the standard use and the implementation. So we've got basic O string stream taken as stream buff type and a const alloc ref. Okay. That's gonna construct MyBase with the std address of our sync buff. Here we qualify address of to prevent any argument dependent lookup hijacking, because although basic sync buff is a type that we, the standard library, have defined, it's templated on potentially user defined traits and allocator. And the standards rules for ADL are extremely aggressive about searching the namespaces of template parameters. So in theory, this could be hijacked and we prevent that. And there's no enforcement, so we need to just enforce it with code review. And then we're going to construct our sync buff with the provided stir buff putter and al. Okay, that's good. No reason for top level const pointer in a one-liner. I think that's fine. Okay, we've got an explicit basic OSync stream with a stream buff type star. Here they call OBuff. This has a delegating constructor. That's fine. obuff and allocator. The standard depicts paren. We often like to construct temporaries with braces. I think the one place where we do not do that is in elements themselves. I recall Casey pointed out that technically there's a conformance difference if the element is weird enough. For allocators, I believe we don't care about that. I think it's a non-issue. I'm not 100% sure. And I do prefer the braces. Honestly, I think the standards should say that they're always the same. So this is good as far as I'm concerned. Okay, we've got another constructor here. This is a copy, but with a allocator constructor. Sorry, it's this one. Should not be explicit. Oh, sorry, it's from a base class as well. So from basic OStream, the Crt Traits ref oster, and a const alloc ref al. Okay, this also delegates to basic OStream constructor with read buff and al. Okay, good. We've got a constructor just from the basic OStream. So this is behaving like as a default argument. This one's explicit, so we can vary the explicitness based on whether there's an argument or not. That's why they're depicted like this. So if you have just an OStream, then we delegate and we provide default constructed Alex. That's good. We got a move constructor that is depicted as no except in the standard. Okay, so let's see what's happening here. We construct my base with move right. That's all interesting. My base is a basic O stream, and we're giving it a basic OSync stream R value. But because the inheritance is public, everything's fine. The basic O stream constructor will only care about another O stream. And there's no potential for a user, because I'm concerned here because we're not providing exactly the right type. We're providing an R value of the derived type, but we control the basic O stream. There's essentially no potential for like a weird conversion. If we were constructing some user-defined type, I would be concerned. Here it's fine. So that's good. Sync buff, we're going to move the right sync buff, okay, because that's got a move constructor. We saw that. And then we're going to set, because the sync buff, or because this class is pointers into its own buffer, even after moving both of them, we need to update the pointers. Otherwise, they would be cross-linked and pointing into the other OSync stream's memory. So we're going to set read buff on address of. Okay, so that's good. The DDOR can be defaulted. We've got a move assignment operator that's marked as no except and defaulted. Okay, we've got emit. If we try to emit and it returns false, then set the bad bit. Okay. There, I'm always concerned about the various bits, so let's check. Okay, calls just emit if it's false, set bad bit. Okay, great. Then we've got get wrapped. Okay, that one's easy. Get wrapped and rebuff, these are observers, so they're no discard, and const no accept. Okay, get wrapped, sync buff, get wrapped, read buff. Okay, this is interesting. We get the address of the sync buff, which is a const sync buff type star, and then this const casts away. Is that? I'm assuming it's acquired. I'm just double checking the const cast. Oh, it's depicted here. Oh, it's in the standard const cast. Okay, great. Awesome. Brace semi, stood end. I think I had briefly checked all the macro stuff, but let's make sure all this is in the present and in the reverse order. So we need to undef after closing stood, undef emit and new, warn and pack. Here's the bottom of this thing. Undef emit and new, restore the warning from Clang and MSVC the pack. And then we checked has6620, compile preprocessor, and underscore syncstream underscore. Okay, that looks good. Okay, so this header is reviewed. Okay, oh, some things have changed. Skip over those for now because those are in response to feedback. Let's see, we've got about a half hour left. We can look at the separately compiled code. Let me get an overview. Okay, that's right. We had a bunch of test code that I reviewed. I think I left the source file and the header file. Okay, so let's. I've been leaving the hardest for last, as I usually do in reviews. I need to build up some momentum and familiarity with the code. The STL separately compiled sources are always tricky to modify. There's so many things that can go wrong with the DLL, with calling conventions, with state, that I wish the entire world were header only. In this case, it is sadly unavoidable. So we do need to modify this. Earlier, we had reviewed all of the build system stuff. Mentioned that the hack these files wiki. So here I'm going to be thinking about, we're injecting this, I believe, into the import lib. And some of this stuff, I actually don't see, let me double check this is being injected into the import lib. CMake list is, yep, it's commenting with like vector algorithms, and I think it was, yeah, localo imp lib file system. We have a comment about the scary nature of this import lib technique, where if we drag in a basic, if we drag in a basic string, we're doomed. Are we dragging in all of the sync string here? No, it's only map and shared mutex. Okay. Map depends on IDL though. Trying to think. We only have 2 import libs. So what I'm mentally going through here is like the worst. This is the worst thing that I ever broke in the STL. It was, or worst thing that we ever found was broken. I think can't remember if I did this, but I was certainly involved in the investigation and fix. We have a macro called iterator debug level that has 5 settings that affects the representation of STL classes for our iterator debugging bookkeeping. And we have 2 DLLs. We have the release DLL and the debug DLL. And for a long time, up until VS 2010, we also had 2 static libs, release and debug. And yet we had these 5 different ways that the iterator debug level macro could be set. This is a one definition rule violation. In particular, if a user compiles their code with a non-default iterator debug level, they're changing the size and representation of their vectors and their strings and so forth. And if they were linking statically against one of the STL's import libs with a different definition of iterator debug level, then that's an ODR violation, the bad kind, and their code could horribly crash. And there is some code written before my time in VS 2005 and 2008 that attempted to sort of paper over this difference in basic string, which never worked. It was plagued by bugs. It was just fundamentally unworkable, and we ripped it out. So in VS 2010, we fixed this by, and this was part of the change I made, we now have 5 import libs for every possible setting of iterator debug level. This is because there is absolutely no isolation. There's no boundary between object files and static libs that are mixed together into a single binary. C++ really requires everything to agree on the layout and representation of stuff that's linked into a single binary. So that's why we have 5 import libs. But we still only have 2 DLLs because trying to add extra DLLs to the Redis would have just been logistically incredibly complicated. Even now, adding additional satellite DLLs is a huge headache. Replicating the main DLLs for the STL was just completely unworkable at the time, and even today would still be a huge headache. So we still only have 2 DLLs, but at least DLLs have a binary boundary. So we get away with 99% of iterator debug level mismatches by saying, okay, STL DLL, MSVCP 140.dll, you are not allowed to export anything that mentions iterator debug level. So nothing whose representation can change. So nothing in the export list of the MSVCP DLL has a basic string as a parameter type or return type, nothing in its representation, certainly no vectors or anything. Internally, we can use basic string and so forth because we are isolated inside a DLL. We just can't export anything that varies depending on iterator debug level. This is 99% true because we do have facets in locales that appear on the DLL's binary boundary. And their virtual functions are mandated to return basic strings. So the one limitation is that a user who's dynamically linking against the STL and setting iterator debug level to a non-default value cannot use user-defined facets because those pointers are passed to the STL DLL, and the STL's DLL will expect a different basic string representation. So you end up with a crash. Somebody rediscovers this every year or so, and we just have to tell them it's not supported. You either need to statically link, or you need to not customize IDL, or you need to not use user-defined facets. So that all works fine, with air quotes around fine, except when anything sneaks into the import lib of our 2, not 5 DLLs. That depends on iterator debug level. This happened around the time of VS 2010. I think we fixed it in 2012, where basic string was sneaking its way into the import lib because it was so easy to accidentally drag it in. And we end up with an instantiation of basic string inside one of our 2 import libs when the user code, which is being statically linked to it effectively, could have 5 different possible settings. ODR violation. It manifested itself as the users got debugging failures. They tried to debug, and the debugger was confused about the representation of basic string. Sort of miraculously, it wasn't actually crashing at runtime. It was just the debugger getting confused in its visualizations, but it had the potential to be much worse. So we fixed that by ripping basic string even further out of the import lib and adding scary comments, which brings me back to what I'm looking for. We expect scary comments, and there I think we may have an issue to track exactly how scary and how consistent we should be about these comments. I believe that's going to occur in that vector algorithms, the X wants to CPP. Let's see if I can find it. Yeah, here we go. So things that get put into the import lib. This was originally in the X facet header, I believe. This, get a permalink by hitting Y. Yeah, same for X wants to. So because this source file is being injected in the same way, we should have this comment. It is a very important reminder that anything that depends on iterator debug level is bad. And so this means that map is not available. We should not use map because it definitely depends on IDL. Okay, where do we usually put that comment? We usually put it right below the license banner. Okay, as this separately compiled source file is being injected into the import lib. Then there's a separate question about, is it okay for the import lib and the user binary to have the mutex, or does this mutex need to live in the satellite? I'm not enough of a DL expert to know about that. I'm going to add a separate comment for that. We may need a different approach. We may need to add this to the satellite DLL. We should have the scary comment for import lib stuff. This is moot if we move this into, because there's going to be a bunch of comments, satellite DLL. Okay. Next comment. I'll just keep commenting on this empty line here. Let's see. We need to determine whether the import lib is the right place for the, actually, I guess the syncstream mutex map comment is better to provide a little bit of context. We need to determine whether the import lib is the right place for the sync stream mutex map. Because the import lib is effectively statically linked to the user's binary, there I don't know about the lifetime issues, but I'm definitely concerned about scenarios such as multiple user binaries, and I'll just provide an example. Meow DLL, per DLL, cat exe being linked to a single STL DLL, MSVC P140 DLL, would end up with separate sync stream, this is a mouthful, mutex maps, one per user binary, which seems problematic. I think it's a bug, but this is outside of my usual core area of expertise, so I'm gonna not say it's 100% a bug. I'm just very concerned. Because this is, actually, let me start a new paragraph. Because these mutexes are global state, I suspect that we need a single copy of them per STL DLL, which means that this needs to be added to a satellite DLL. That would be the atomic weight, or let me say, for simplicity, for ease of development, the atomic weight DLL recently added for C++20 is probably best to extend despite the name. Stood C++ latest is not yet ABI frozen, so we can add exports to that DLL, which will be massively easier than adding a new satellite DLL. Like the misery that we went through to add the satellite DLL to the CMake build system and the MS build system and set up authoring was just completely horrible. It's a process problem. We need a written down process for here's the 50 zillion things you got to do when you add a satellite DLL, and we don't have that written down anywhere. We discovered it gradually through the last satellite DLL, and we still didn't write it down. Billy O'Neill was working on properly documenting that, but that has not been achieved yet. So to avoid the pain, extending atomic weight is probably best, which is funny because we had initially named our satellite DLLs _1 for special math, _2, I think, for memory resource. Then we noticed, wait, these names are inscrutable. Why don't we name them nicely? So then we had code convert IDs and atomic weight. And now we're going back to, wait, if they were just numbered, we wouldn't have this naming clarity issue. So we can just never win. Okay, so I'm pretty sure this needs going to satellite DLL, unless I'm wrong about the mutex map. I could be wrong, but it seems that if you've got Meow DLL and cat exe, and they're both trying to simultaneously write to an OSync stream, they need to agree on the mutex. And if the mutexes have been linked into the user binary separately, there's not going to be any actual concurrency, protection there. So this is, I think it's got to be global state. I hate separately compiled code. It's so much to think about. And the consequences for getting it wrong is just you ship something and stuff crashes and you can't fix it because now you're locked in with ABI. So that's why, even though this file is only 70 lines, it's a headache. Very, very glad that Mike Rizkal is contributing this, because this was sort of why we had left it until the end. Okay, so I had commented about the scary comment for import lib stuff. I commented about the import lib. There was one more thing I was going to comment. Yes, it's that map is problematic. Okay. As an STL or map is an STL container whose representation is affected by iterator debug level. This means that we can't drag it in to the import lib due to ODR violations. There are only 2 DLLs import libs for release debug. Yet there are 5 possible settings for IDL. This is the scenario that the scary comment for import lib stuff warns against, with basic string as the example. This may be, if this code is moved into a satellite DLL, as I suspect is necessary, then this issue is moot. Satellite DLLs can freely use, can use STL containers without fear of ODR violations because there is a binary boundary. Okay. Maps an STL container whose representation is affected by iterator debug level. This means we can't drag it into the import lib due to ODR violations. There are only 2 DLLs import libs for release debug, yet there are 5 possible settings for IDL. This is the scenario that the scary comment for import lib stuff warns against, with basic string as the example. If this code is moved into a satellite DLL, as I suspect is necessary, then this issue is moot. Satellite DLLs can use STL containers without fear of ODR violations because there's a binary boundary. Okay, this is like the this is why code review is most important. Is these sort of large issues that are not obvious at all from the source file and depend on human memory, and we should have better documentation around what it means to put stuff in the import lib, but there's always going to be issues like this. Okay, so copyright license, bunch of comments about the overall architecture, initialize Syngster mutex map. Okay, internal shared is for this initialization stuff, which occurs in other import lib stuff. Basically, it says you need to initialize any static data here really early before any user-defined static objects, which is why you have that. Aside from dragging in map, we're going to use map and shared mutex to find some stuff in stud. Object declarations. Not sure if this banner provides value, but okay. We've got a mutex count pair, which has a shared untimed mutex, which requires, this is now a dependency because we've never really used shared mutex internally before. Shared mutex depends on Windows 7 or above. Does not permit Vista. That's fine. Vista's totally out of support. I wouldn't even think that we need to document this. Not concerned there at all. Because it's a CS+20 new feature. And we've got a UN64T ref count with an data member initializer starts at 0. Okay, that seems fine. It's non-copyable because mutexes are non-copyable. Okay. We've got a Crt Allocator. This is going to mark things as Crt allocations. That will prevent them from showing up as leaks. Okay. Okay, so this needs to follow the form for user-defined allocator. Some of this is unnecessary though. Value type is necessary, but size type and difference type are not unless we need to use them internally. And here this is just referring to size t. So I'm going to comment that these are not necessary to define. The Pokemon is always equal. These are fine. In fact, I think the standard allocator does. In fact, I suspect this was substantially copied from the standard allocator, which does refer to these, I think. But these are defaulted. Allocator traits provides these as defaults. So these type defs are necessary. And they aren't used anywhere as far as I can tell. Yeah, okay. So we don't need that verbosity. But Pokema and is always equal or fine because this makes CodeGen more efficient. Actually is always equal is not really necessary either because the type is empty, but I think this is okay. Whereas these type defs are just really unnecessary. Okay, so we need a default constructor. It can be const expr even though you're, well, eventually we're going to care about const expr allocation, just not for this class. So default constructor can be const expr, no except defaulted. We're going to have a copy constructor and a converting copy constructor. But I'm mentally going through all the allocator requirements. Usually I would need to open up the standardies, but I've seen so many of these that I've essentially memorized it. The rebinding type stuff is provided by allocator traits, but you still need a rebinding constructor. So that's fine. You got allocate with all of our non-standard stuff. It's marked as decospec allocator for the debugger. It's marked as CRT guard overflow, which prevents some type of some incoming integer overflows that otherwise we can't detect because they would happen before the size t is given to us. We try to call calc CRT with count objects of size of tie, store that in putter. This doesn't really need to be top level const. Yeah, but the function is more than one line. Mentally thinking, yeah, I'll say this could be top level. I love const so much. Okay, this could be top level const. If we didn't get putter, then throw a bad alloc exception. Try to think if we need to call that x bad alloc, but this is separately compiled, so that's fine. If we did get it, then let's static cast provide type information. Looks good. Deallocate is going to call free CRT. However, if you have an unnamed parameter, there's no point in marking it const. We conventionally don't mark unnamed parameters as const. No danger of modifying them. Smile cat. Okay. Gonna free CRT, which will accept null. That'll be paired up. Okay, here's that usage of the map. It's map from void star. Plus void star, and then an allocator of the right type, which is indeed top level const of void star. Thanks, map. Mutex count pair. Okay. And then you got a static mutex. Nothing has been seen with this name. Let's see, this is within stud, so we don't need to worry about taking a user-defined name, and it's all ugly, so that's good. Thinking about shadowing, this is a member of mutex count pair, so no possible shadowing with this top-level mutex. Okay. And then implementing, I see that these are now stud call. We'll finish this file, and then we're at the end of the review, or the time slot for the review, I should say. These are extern C. No discard, CRDIM2. We're in 20 mode, so we don't need to care about CLR pure. We return shared mutex star, get mutex for instance. Okay, so we're gonna use ctad to construct a shared lock for shared mutex called guard. Good. We're gonna try to find in the mutex map this pointer for void star. Okay, so this is how we magically construct the mutex. We assert that we found it. Okay, because we assume that it's already been acquired. So we're going to assert, interesting that it's assert expr, that we found it, and if we did, then get its mutex and return address of. Okay, here I think we don't need stat address of because we're in separately compiled code. This is a shared mutex. We control the type. No possibility of hijacking. We can just say ampersand. I will suggest that here. All the arrow and dot bind tighter than address of, so precedence is okay. This is separately compiled, and we control shared mutex. So there's no need to, or sorry, I said ADL hijacking. It's the stud is for ADL hijacking of address of, the address of is for operator address of a hijacking to defend against overloaded operator address of, so we can write code like normal humans. So strange. There we go. Okay. Iter second mutex. Okay, this is doing a single lookup, which is great, rather than like doing a find and then a square bracket, which would be bad. Okay. Next, if we are, I'm going to add a nitpick. This is a white space nitpick. We conventionally separate function definitions with a new line, except when they are very short and very repetitive. Okay, here's below. Okay, so if we're trying to acquire mutex, we're going to take a. Okay, so scope lock versus shared lock. This one is reading, so shared lock, because we're not actually modifying anything. So it's okay to have multiple get mutex for instances simultaneously trying to find the mutex. Okay, so that's good. But when we're modifying, like acquire, which is emplacing or erasing, then these need to actually acquire writing locks. So these need to be scoped locks. So the difference is very important. Okay, so that's good. Here we're going to try and place for the void star. And then when we do get a map, okay, there's a lot going on here in the type system. We're going to try and place a pair with key of putter. If we succeed, then this returns it's like a pair iterator bool. We don't care whether it was emplaced or not. Wait, why are we doing try and place? Hold on. Now I actually need to see what try and place returns. I've not memorized this new function in map. Containers, associative. It's also in the container requirements, but I just need to see the signature. This is my go-to definition. Let's see. Okay, try and place returns an iterator bool. This says try to emplace it. And if you can't, is this the one that assigns? Let me see. I should know this. It was C plus 17. That was years ago. This is going to be in the container requirements for associative. Okay, tell us what try and place does. Yes, in place is the one that Yeah, if it already exists, or it's unique. If it already exists, then don't do anything. What does try and place do? Hate these tables. They're finally going to change that in the standard. It's going to be great. Did I go too far? Yeah, I think I went too far. Let me maximize this. These are in place. Is try and place not in the table? I think it may only be in the, maybe it's only in map. Okay, let's go look at map. Modifiers. Okay, it's only map. Try and place for key. Oh, that's why it's on map, because it separates the key and the value. If the map already contains an element key equivalent to k, otherwise inserts an object, the bool is true if and only if. Why do these differ from in place? Oh, because the key, sort of dredging up my memory here. Why does this differ from in place? Because in place takes an entire value. I think. Sorry, let me look at the definition. Oh, that's right. It's here's in place. That in place is the entire pair and returns pair iterator bool. And try in place is given a key already. Ah, that's right. It's all coming back to me now. In place is just given stuff to maybe construct a node. And in general, we need to actually construct a node before we have a key to compare and see, is this thing already in the map? That's not super efficient. We've got some metaprogramming. We've had long-standing bugs, which I think one is even still active, about optimizing this and avoiding construction if we can possibly avoid it. But try and place is just given a key, so we can compare to see if it's already in there. So that's what's happening. Okay, so try to in place putter, and then we're going to construct nothing for the second argument, the value, the mutex. First is the iterator. So here we are going to get an iterator to the value. Okay, and then second is the mutex component. Okay, and then ref count. So my one comment here after going through all that is that we conventionally prefer pre-increment. Here, there is no reason to pre-increment versus post. So even though it will look strange, it should go on the left. We conventionally prefer pre-increment, except when it makes me necessary post increments stand out. Okay, so try to in place, and then I believe it returns. I don't need this anymore. If it was already there, you get an iterator to the element. Yeah, no effect, and then yeah, returns to the map. Okay, so if it already exists, then you get the iterator to the thing that's already there, and then increment its ref count. And if it's fresh, then you get 0, you increment to 1. So that looks good. Release mutex. Okay, this is a write, so scoped lock. Try to find. Asking whether this should be top level const. We are not reseeding the iterator, so this can be top level const. Okay, we really should find it. And then this is interesting. So if we decrement, if it hits 0, then erase. Question is, do we care about multi-threading? Could multiple threads simultaneously release a single mutex? This is interesting because it's using a reference count, but it's not actually using shared putter or anything. I'm a little surprised at this. I need to see, could multiple threads simultaneously? I may just need to leave this as a question. Okay, so what's happening here? One place where we do this is when we're tidying on sync buff or basic sync buff. When we construct, we acquire mutex for this particular pointer. When we destroy a particular sync buff, if we had wrapped, we're going to release. So we can absolutely have multiple OSync buffs basic sync buffs on different threads, simultaneously acquire mutex for a given sync stream. That was the constructor arc, right? Yeah, for a given stream buff type, which is the basic stream buff. This is its whole purpose in life. And this map is supposed to guard simultaneous writes to the underlying sync buff or stream buff, which is why we've got these mutexes. But the ref counts themselves, there's only one, like they're paired with the mutex. So these are multi-threaded operations. Plain increments and decrements are not correct here if I understand what's going on here. This really looks like it needs to be powered by shared putter or equivalent tech. And yeah, it would be another layer of indirection. So what is oh, sorry, this one mute. Oh, wait, is this what's going to save us? This may be what saves us. Yeah, okay. We're okay. I freaked out a bit there. We've got the mutex map, which is of course, not multi-threading safe. And then we've got a single shared mutex. The map itself is a map of shared mutexes that we're going to hand out for each individual buff. But we protect the map and all of the ref counts inside with a single shared mutex here. Okay. So here we're reading, and we're not incrementing any ref counts. But when we acquire this, we can both arbitrarily modify the map because we know that we're the unique writer, at least for this particular map, and we can modify anything within it, including the ref counts. Okay, so we don't need interlocked operations. This is safe. Okay, I was very worried. Okay, so that's good. And then we erase. This is another log lookup. This should not be necessary. I think we should erase iter, not erase putter there. Erase does take an iterator, doesn't it? I forget how maps work. It does. I'm just checking. Place, assert, erase. Yeah, it takes a key. It takes an iterator. This is log time for the rebalancing, but at least it already knows what to erase. So this, I believe, should be this here. Now, find putter, erase putter. That is the key. So this will perform another log n lookup to find the putter key. It would be strictly more efficient to erase iter. Yes. Yeah, that looks good. You find in a single login operation, and then if you decide to erase, you already have a pointer to the node, and so then you have the unavoidable login rebalancing, but you're not doing another lookup. Okay, must stay alert to the very end of the code review because a single identifier that compiles may not be efficient. Okay, and then close, and then student. Okay, so that looks good. Okay, so the biggest, we're now out of time. Sorry for going over a bit. Biggest issue we found is just where does this code live? And I think I've come to the conclusion that it really needs to be the satellite DLL. I don't see how this could work with an import lib, even with my imperfect understanding of DLLs. I'll probably want to ask Casey when he's back, because he's done more of this import lib stuff, or import lib and satellite DLL than I have. But my understanding is this needs to be shared across a single copy of the STL. Like if we could modify the core DLL, MSVCP 140, we absolutely would here. And I think because the global modifiable state, we must put this in the satellite. It's not like file system, where file system needed separately compiled stuff, but they were just support functions that access the Windows API that we can't drag in header only. There's no global mutable state that we needed to care about. So SingString is different in that regard. Okay, so I will submit my review. I will request changes, and at some point I'll come back and review the files that have actually changed, make sure that my preceding comments were addressed.
Stefan, can I ask a quick follow-up question?
Yeah, sure.
I was talking to Casey about this morning in his office hours meeting, and specifically about some of the DLL stuff that we were talking about regarding the ICU API for
Yes.
the time zones. And it seems to me that, so you were kind of drawing the comparison of like the file system use of the separately compiled stuff versus mutex, which uses that globally shared state. And it seems to me like ICU would be more in line with the file system side of things. From what I am thinking, I'll go review the chrono pieces soon, but from what I'm thinking, it's similarly just using functions to kind of get information. There's no globally shared data that needs to be maintained just for the time zone information. Does that sound accurate to you?
Yeah, that sounds exactly accurate. Although we are querying state that exists in the OS that is modified during Windows updates and who knows what else. The STL itself would not be maintaining anything persistent and modified, except for like caching a pointer to the DLL that we're loading, the ICO DLL. And it's totally fine if in this multiple user binary scenario, if meow DLL, per DLL, and cat exe all have separately loaded the ICU DLL and have handles to it, that's totally fine. There's not going to be any sort of mismatch or them getting confused about what's been loaded. So I think the ICU case will be a perfect candidate for being injected and will not be affected by what's going to require SingString to be changed.
Okay, great. I've learned new words this morning that those they were said, so I wanted to make sure that my understanding was correct. Awesome.
Yeah, absolutely, and yeah, thanks for checking, because the DLL stuff is so easy to get wrong. And
For sure.
nothing tells us until after we've shipped, and then it can be very painful to go fix things later.
Yeah. I think Cameron also had a question in the chat from 37 minutes ago, but it's
cool.
still
Let me see.
relevant.
Do the ABI concerns exist in the debug DLLs? Customers cannot deploy them to observe any possible ABI breaks. That is a good question. I believe that the thing that we're really worried about, which is like this print driver scenario that prevents us from adding extra exports to the DLLs, because they're specifically not redistable, I think we could say, yeah, the debug DLL, we could add new exports to it without being concerned about ABI. Because if you were concerned about an existing installation, well, actually, sorry, I'm a little bit wrong there. There is a way. It's not supported for users, but installing VS does install the debug DL into System 32. So we could potentially run into a situation where somebody installs a new VS and previously compiled developer sort of mode applications that were being loaded in this weird print driver scenario. Not exactly a print driver, but the specific scenario that I would need to go look it up, could be broken. But I think that question is ultimately moot, because even if we could add extra exports to the debug DLLs specifically, we would be doing something different for debug DLL versus release DLL. So it wouldn't save us any simplicity. And in fact, it would make debug applications resemble release applications even less. We already have, the whole reason we've gotten into this trouble is we're making debug applications do different things with different representations. But at least right now, we can sort of rely on at least the debug mode has substantially the same exports. I think there are a couple extra exports for like debug only functions, but it's generally extra stuff appears in debug. Not that, oh, we can just fuse things and get them from the main DLL rather than satellites or import libs. Any extra complexity there could potentially lead to user confusion about, oh, this worked in debug and doesn't work in release, or vice versa. Or at least for us could lead to confusion about exactly what scenario is happening. One of the things that at least makes it a little more reasonable for us is structurally they're the same, even if the sizes of the types are different. But that is a great question. Thanks. Okay, if that is all the questions, yeah, it looks like in the chat those were all the questions. I will submit this review offline, and then later I'll go back and check the commit that was made, make sure that my concerns have been addressed, or at least we're making progress there. But overall, I think I've gotten through all the files here, which is great. And hopefully the change needed to move this into the satellite DLL will not be massive, because it will just be changing the files that affect our build system and the internal build system as well, and possibly changing the specific annotations like CRTM2. I think that will need a change for the import lib to satellite DLL move. But the actual structure of the code, it looks solid to me. After reading this, I feel more confident that I understand what's actually happening, even though IOStreams is still sort of eternally opaque to me. So hopefully this has also been somewhat enlightening for IOStreams and multi-threading and dependent lookup and all that stuff. But if you have questions, feel free to ask in the libraries channel or on Discord. So thanks.
Sounds good. I'll stop the recording. Thanks, everybody.